are you, Brian? You're viewer 5?
I believe so.
Just put your name. If you click on the...
Change my name.
Yeah, change your name. Put Brian Powell.
Oh, yeah, I guess I should do that.
So many friends.
Okay.
One of those days.
All right. Can you check with them if they can hear us? How's it going?
Hello.
So just check if they can hear us. And then,
Yeah, I'm typing.
then let me know. If not, what we can do. I think that...
It says yes.
Yes? Okay.
You can.
All right. All right, so we're ready to get started, guys. So first of all, I wanted to thank Darren because we didn't have a sponsor for food. And he called me and said, do we have food? And I'm like, no, bring your own. And he's like, okay, I'm going to go and grab some burgers. And he brought burgers for everyone. So thank you, Darren. Hopefully in the future we do find a sponsor because I also did a dash run to Costco to get some turkey pinwheels for those that cannot eat beef, and the chips and the soda. So I've been slacking a little bit lately for the LabVIEW Architects Forum. We only have one presenter today, and that's because I have not been harassing the usual suspects as I normally do. So if there's anything you guys want to present, please let me know. Who's going to go to NI Week? Who's coming to NI Week? Okay, so here is and also for the people that are joining remotely that are going to come to NI Week, here's your task from the LabVIEW Architects Forum. You're going to attend tons of presentations. I want a list of which presentations you want to see here or a follow-up of those presentations. And that at least will give me something to go harass a new list of people. Invite a new list of people.
They don't let me attend sessions. I spend all my time talking to people.
So that's your task for NI Week, okay? You also have to go to my presentation. No, just kidding. Mine is on Thursday, so by the time my presentation happens, you're all going to be already tired. So anyway, so that's it for the things. We have one presentation. After Brian presents, there's open mic, so if anybody wants to discuss something in particular, we can have a discussion about it, and if not, we'll just end up early. All right, so when Brian said that he wanted to present, I was like, seriously? I'm very excited because Brian he's been a mentor to me. He's a very good friend, and I have always admired Brian and been inspired by him. And I'm really, really happy that even though he left tonight, he has not completely left us, and I'm going to cry. So I'm going to just let him present. All right?
Thank you. Are you...
Yep. I guess flip over to join. Yeah, hit accept. Yes. Allow.
Sure.
Okay.
Maybe I'll just kind of keep that somewhere. Okay. I'm hoping everybody can hear me on the phone. So do I have to keep saying allow, or is there somebody else who can take over that job?
Yeah, I'm unlocking it. There we go.
Okay. Now I'm going to hide that. Okay. Somebody just left. Wow, that's awesome.
Got all I needed in this meeting.
How many of you don't know who I am? You're lying.
Yes, I am.
Okay, so some of you may not realize that I left NI in mid-May. One of the things that I've been doing, I just want to kind of give a little bit of background. I'll get into the actual presentation. But one of the things I was doing the last 3 years at NI was helping a lot of our customers be successful. And when you know it, a lot of helping our customers be successful had to do with helping them build strong software teams and good software engineering practices and things like that are almost LabVIEW agnostic. So a because that's, think about it. A lot of NI's customers are not trained software engineers. Yet, we give them a tool, require writing software, and so if you don't do good software engineering.
Mute, please.
Yes, mute on the phone, please. If you don't apply good software engineering practices, you will probably fail. That's one of the things I saw a lot with certain customers is that they just didn't know what they didn't know about good software. So one of the things, that was really inspiring to help our customers do that, but one of the things that also inspired me to do is, hey, maybe I should find a software team to actually help grow and teach them how to build a good software.
Hey, your line.
I think if I...
Turn down the speaker.
Yeah. Okay, can they still hear us? Right.
Try, Ryan.
Okay, let me know. Okay, so in early June, I started at a company called Athenahealth. It is approximately that way on the other side of Mopac. And it is a small office of about 40 people when I started, with plans to grow to 600 people in 10 years. And so I thought, that sounds like a really cool problem to work on. Doesn't matter what the technology is or all that other stuff. It's growing a software team from 40 people to 600 is going to affect your culture, your process, a whole bunch of things. It's going to stress a lot of that. And if you're not careful, you can really screw that up. And so that's one of the reasons I went across the street, is to help a team do that. So I'm excited to be part of that. Athenahealth, for those of you who don't know, basically does cloud-based medical practice software. So running the business side of a doctor's office in terms of getting paid by insurance companies and scheduling patients and patient communications and referrals from one doctor to another and all the things that an insurance company wants to know before a patient gets treated, et cetera, as well as electronic medical records, all these things mandated by the government. So we have a bunch of cloud-based services to do that, and that's also kind of important, helping improve healthcare, lower costs. Especially, we're really successful dealing with small doctors' offices where they can't afford an IT department to deal with this. They can't afford security specialists and all these other things that you need to be competitive and to also follow all the rules. So anyway, that's kind of what I've been working on for the last month and a half or so. So it's a really cool place to work, and I'm excited to be part of that. I'm also excited to still be part of the LabVIEW family. So I'm excited to be here today. I'm excited to come to NI Week, where I still got 2 or 3 presentations that I will be doing. Let's see, this particular presentation is a variation of one I did for the CLA Summit in Geneva. And a lot of the edits to this presentation from Geneva were changing from the NI PowerPoint template to the Athenahealth PowerPoint template. So for those of you who were in Geneva, this is maybe a little bit of a repeat. But a lot of one of the things about the CLA Summit is that the content is very much discussion oriented. So I want this to be very interactive with people on the phone, with people here in the audience, to let's discuss some of this stuff, and it's not just a one-way presentation. So same thing applies here. And I'll also just mention that that's the best email address to get hold of me. If you guys, Brian@ni.com, no longer, just get a Brian no longer works at NI email. So use this one. I have an Athenahealth one, but I really don't want to read your emails at Athenahealth. And then LabViewJournal.com is the blog that Nancy and I created, and we haven't updated in some time, but I have designs about a
couple of blog posts that I want to do. They're around the idea of software engineering. And then I think Nancy has some ideas of stuff she wants to talk about. Okay. So the topic here is being a humble programmer, or it's based on a blog article I wrote on LabViewJournal.com called Humility and Better Programming. And even the word humility even came up across the street where we talked about, guess what? The code base across the street is somewhat old, somewhat large, somewhat homegrown, poorly documented, with a bunch of homegrown tools around that, and and I felt just right at home. But we talk about, if you're writing software that's going to last many years, then you kind of have to have a certain attitude about how you write that code. And so one of the things that Athenahealth really pushes as part of the culture is a teaching and learning culture. So everybody is expected to be both a teacher and a learner. And so I've got a couple of quotes here about learning from others, because there's plenty of stuff to learn from others. So one of my themes on being a humble programmer is being willing to share your knowledge, and that's also how you learn to be a better programmer, is learning from other people around you. And then I also like this quote from Winston Churchill. I think Chris Relf either pointed me at this or just, pointed me in the direction of Winston Churchill. But I think this is also true. So way back, this is probably LabVIEW 3 time frame. Actually, this is probably LabVIEW 3 time frame. We all have our 3D glasses on. Bruce Mahura is sitting at the table, sitting at the computer, has written some algorithms for doing 3D. Thanks for adjusting these lights. I'm in the spotlight. If you turned that one off, it would help. Yeah.
There you go.
That would be great. Okay, so this is just the we're all kind of huddled around learning about what Bruce is working on, and that was just learning from other people is something in the LabVIEW community. In the back center is Duncan Hudson. Many of you know him. Greg McCaskill's on the far right. Several of these people are still at NI, still part of LabVIEW R&D. This is like my first year at NI. I had hair. That's the biggest change, I think. I was skinnier. And I had a whole bunch of books behind me, mostly about X Windows and Unix and how we were going to figure out how to port LabVIEW. I learned so much about programming from working as a professional programmer in LabVIEW R&D. I spent 23 years there, and I had the best mentors, people like you saw on the other slide, people like Steve Rogers and Rob Dye and people like that. And that's where I really learned how to program. And I wrote code. There's probably code still in LabVIEW that I wrote when I was that young, except I didn't know that it was going to last that long. And so that's another part of this is, even if you don't expect your code to last for 10 years or 15 or 20 years, there's a good chance that it might. How many of you have ever written a prototype and then shipped the prototype? Yep. So there are 3 of you that raised your hands, and the rest of you are lying. And that's very common. There's that happens across the street. So, but I think it's important to either learn how to throw away the prototype, which it's a good thing. And I know in the LabVIEW R&D team, they threw away the prototype more than once. LabVIEW 1 was a prototype, and we rewrote it from scratch for LabVIEW 2, for example. And that's good to do occasionally. some of that code is going to survive, and if not, if not in actual code, and at least in spirit. And so, thinking about how to construct your code in a way that can survive that. So, what do you think some of the traits are of code that is likely to last, say, 20 years?
You wrote it for the military.
You wrote it for the military, so you have no choice. They can't afford to modify the code. But, part of surviving 20 years, I phrase it that way, like surviving, what makes code survivable for 20 years? Because if it's crappy code, is it going to survive 20 years? Like if it's,
In some environments, it might.
let's say it doesn't work. Say it doesn't do its job.
Of something that's true, a lot of code survives that long because business interest decided it has to, not because the code is any good or it works right.
Yeah?
You do medical record software, you know that.
Yeah. Yeah. Getting a little close to home right now. My project today. So, if code is really bad and there's a business reason to fix it, then it'll get fixed, right? If code is really bad and there's no business reason to fix it, then who knows? Maybe it'll get fixed if, some developer decides to, sneak it in. I've seen some code that just like, I need to fix this.
Are you asking? So I think your question is more along the line of how does you come back to that code that has survived for 20 years and is actually something you want to touch, or do you have to burn it all down because it's so awful?
Well, or let me we've just used some examples, kind of counterexamples of code that ought not to have lasted 20 years. And there can be plenty of code that perhaps shouldn't have lasted 20 years but does. But there is also plenty of examples, I think, in LabVIEW source code, for example, that deservedly, was for the most part not changed over a lot of those 20 years because it didn't need to be changed. And so what might some traits be of code like that? Yeah. So for the people on the phone, Chris said that well-designed, paraphrasing, well-designed code with a particular purpose, well-understood purpose. And I think, you started the words coupling and cohesion, kind of good software architecture stuff. Yes, Alan.
Good. At a very high level, if the code you write has a good sense of responsibility, what it owns, what it doesn't own, what it should know about, what it must not know about, you wind up with a piece of code that is self-sustaining. It's not going to get changed when something around it changes, which I think adds to its longevity. And it's easier to fix, easier to maintain.
Yep. So again, the words coupling and cohesion come to mind in what you just said.
Abstraction and encapsulation.
Norm!
Encapsulation and abstraction.
Yep, very good words. Encapsulation and...
in that little area.
This is my
That's
office.
all they had room for back then.
This is my new office across the street. My hair is growing back and everything, losing weight.
Yeah, the change. Why, you look 20 years younger.
Yeah, if not at least. Yeah, that's the old days. We had a bunch of maps on the wall. Just for historical purposes, just because I know that people like some of this stuff. This ADM3A terminal right here next to Steve Rogers was also called the Proctoscope because it was the primary debugging tool of porting LabVIEW to Windows. And it was basically a serial port connection to a PC with some sort of low-level debugger that wasn't very friendly. And the rest, he wasn't using it for that at the time because we were all on Macs at this stage. But anyway.
Why is there a map of Alaska?
Because I think Steve had just come back from Alaska. Steve and Marilyn had spent a vacation up there. And then this is the Highland Lakes. So here's the city of Austin, Lake Travis, and Lake Buchanan up here. I don't know what else. Here's the whiteboard where a lot of, this is the algorithm presented right back here to the far left.
I'm just still trying to get over the cheesy
Still relevant today for programming. Okay, so a lot of this presentation started with the discussion about with my team, Charlie, and especially Charlie Knapp, who's on my team in Southern California, and he was reading this book by Steve McConnell called Code Complete. So many of you are probably aware of this book called Code Complete. Great book, kind of thick, but it's a good read. And it has this chapter that the theme is basically your personal character directly affects your ability to write computer programs. And so that started me thinking about a bunch of other, there's some of the early computer science stuff where they were really trying to figure out what software engineering was. Right? People were writing programs in the 50s and 60s and just writing crap, and it was hard to maintain and buggy. And some really smart people started to think about, well, how do we actually engineer programs in such a way that they are maintainable and well-written and so on. So before that, it's just people writing code. So software engineering didn't really exist until like the 1968 NATO summit, when the Army and other groups, other European organizations also kind of came together and said, look, we've got to address this software issue. Okay, Code Complete. Second edition is what they're up to now. I have the first edition, which is also good, and there's like 90% overlap, but there's actually some differences. You can get this on Kindle if you want. So I got Code Complete 2 on Kindle just to get an updated one. So just to dive a little bit deeper on that, one of the things, and maybe I've got another quote in here, is it's the computer program, the computer itself, the compiler, something like LabVIEW, it doesn't really care whether your code is well written. It's easy for it to deal with what you put in front of it. It's the human beings that look at your code. They're the ones who struggle with bad code, right? Compiler like LabVIEW can deal with you. You can have wires miles long going all over the place. That's not really that big an issue to LabVIEW, right? It's an issue for anybody else looking at your code. That makes sense? So Dijkstra. So Edgar Dijkstra is was one of the giants of computer science. He was at Eindhoven, Netherlands, for many, many years. Did a lot of the early, thought process on computer science. Invented programming languages. And then he also worked at the University of Texas when I was a student, when I was in graduate school there. And so I really like this, and this, in fact, is kind of where the blog article title came from. This whole idea of you need to approach this programming with humility. And the last phrase of avoiding clever tricks like the plague is, to me, a mantra that I think is really important for people to just always have in mind. Not to name names, but there have been people in the LabVIEW R&D team. I don't know whether they're still in the LabVIEW R&D team. They may have left and come back and corrected their ways. But who just love to show off the clever C++ programming tricks that they could do. So you look at a line of code, and it doesn't do what at all you think it does, because they're doing some clever things inside of this class that you just don't know about. And so, to me, that's an example of we should not have that code. We should get rid of that code. We should rewrite it. to make that clever trick be explicit about what is going on, so that because that code is just not maintainable, right? Fabiola.
There was another quote, I don't know if it's related to that it takes a bigger brain to debug code. So if you are making something so clever and so smart, that means you're too stupid to debug it.
Yeah. Yep. And I have forgotten a lot of the code that I wrote. So even if I had a clever trick in there, I may be the one coming back to look at it, and I've forgotten what clever tricks I put in there. Did you have something to say, Norm?
Yeah, actually, I was curious to expound a little bit more on this when it comes down to the strength balance between doing stuff the same old way and trying to advance things forward. Because I mean, yeah, I understand there's this too clever, and then there's probably a good amount of not so. What's your, like, if that's a personal mantra for you, how do you, what's your model for maintaining balance?
Well, I will start, because I want to hear from you, because I know you have an opinion on this, because we've talked about this before. So, there's this concept called s'mores. Scalable, modular, reusable, extensible, and what's that last S? Simple. Yes. See, and my position is that simple ought to be the first S. So that's my position. Discuss.
One of my early mentors maintained that what you wanted was smart code, not clever code. That clever code was actually bad for the reasons you're mentioning. I mean, there is a difference between smart and clever, right? Smart is elegant, understandable, all the things that we like to see, good delegation of responsibility, good encapsulation, abstraction. It makes sense. Clever is trick. And too much clever.
Yeah.
Clever is a trick. And sometimes we have to be clever, right? Sometimes we're just up against some limitation.
Yeah, one of the things to be clear about is complex versus complicated.
Mm-hmm.
Right? Complex code, assuming that it is appropriately complex, may be fine. Complicated code, especially when it doesn't need to be as complicated as it is, then that's probably a problem.
Multiple parallel loops is an inherently complex problem.
The actor framework is an appropriate solution if you happen to have a problem for which the actor framework is an appropriate solution of, multiple parallel processes that need to communicate with each other. What was that, Staab? Okay.
So I think that's distinction. So we've got this word humility that's floating around a lot. I think humility means a lot of different things to a lot of different people. What are some characteristics or manifestations of humility you think would aid in somebody writing good programs?
I'm getting there. I think the short answer is that I am willing to be a teacher and a learner when it comes to that code. That's part of it. I'm willing to share that code. I have nothing to hide. I don't have any clever tricks that I'm trying to sneak past anybody, for example. And I can explain it to you, explain it to anybody in this room, and they would understand it, appropriate to the skill level of the people in this room. Right? One of the things Nancy and I have long talked about the actor framework is where we see people struggle with the actor framework is people even understand LabVIEW classes. I'm sure you've seen that too, right? If you're just really a novice with LabVIEW and then we throw the actor framework at you, failure, right? It's the same thing with like Compact Rio. We always said one of the worst things you could do for a customer is take a Compact Rio and put it on their desk and say, good luck, and walk out the door, because they're going to fail, right? FPGA programming is different. And so understanding the audience of who you are interacting with, and then coming as an architect, then I think it's your duty to come up with a solution that is appropriate for that kind of audience. And so that's also got some humility in it. Just because I can do some amazing things and make LabVIEW sing doesn't mean that that's an appropriate thing for whatever group I'm working in.
But you still have to solve your complex problem.
Yes, I do.
So sometimes what you have to do is help the people around you better.
Yeah.
I agree with what you're saying. I had experience with university people whose domain or study was incredible. They're brilliant people, but they didn't need object-oriented to get going, right? They needed some complexity, but they didn't need advanced methods. They really do have to tailor that method, your approach to going to the methodology. You're willing to draw and do code in a way that you hate to do it, but because that's how they understand it, you have to show it that way.
Yeah. But as another example, one of the customers that I visited once up in Dallas was, beginning of the day, said, the manager said, I do not want my team to learn OO. It's too complex. And my team doesn't need that. So then I started looking at his team's code and, kind of diving into it. And I pointed out some ways where, if you apply some object-oriented stuff to this code, it would make it simpler and easier to maintain. And by the end of the day, he signed up half his team for OO training just to learn, basically to learn that skill and then hopefully learn it with enough knowledge to decide when to apply it and when not to apply it. Just because you have that capability doesn't mean you should always apply it. But if you don't know it at all, then it's never going to be, you're not going to be able to simplify your code without learning more. So I think that's another part of the humility thing. It's the learning part. I need to be willing to learn more so that what maybe initially looks complicated might not actually be complicated once I learn a little bit more.
Well, that implied there's kind of a perverse arrogance in these are the only tools we're ever going to need to solve our problems.
Mm-hmm.
Well, how could you possibly know that? Okay. Because your problem is guaranteed bigger than you realize.
Norm, do you want to burst out anything?
Well, nothing too different from what was said, but I would like to just reiterate the difference of cleverness in terms of like the way that you put it, like some hidden feature that like, oh, if I do this here and I do this there, and then all of a sudden it makes it do this behind the scenes. Kind of exposing something that was like the idea of callbacks in LabVIEW, the ability to actually fire a user event to fire off of the eye in the background. I think that kind of crosses that boundary of clever trick in LabVIEW, where it's like, this could be really neat, and then all of a sudden I go and I talk to somebody in LabVIEW RD, they're like, please never do that. That's definitely that threshold, but dynamic events would be an example of something that somebody, I guess that definition of clever versus just a damn good practice, that's where that level of experience comes. And you mention that person up to that point where it's no longer possibly clever to them, where it's actually, I guess the two have to go hand in hand.
Yeah, and I think, I put a lot of responsibility on having a good architect or technical lead to make those kind of decisions. I think that's part of building a strong software team, is having some more advanced decision makers who are actually able to understand those trade-offs and be unafraid to not use clever tricks, even if it might have ended up with a shorter program. You know, Jeff Godosky, great guy, but when we first started on LabVIEW, he loved those one-liner deep, 200 character lines of C code that did all the side effect stuff, and that's where a lot of the wiring code in LabVIEW was written like that. Don't waste those bits. And so that code was stuck around longer than it should have because it was really hard to refactor because it was so clever, right? So that's an example of it works, don't touch it, and that's one of the reasons the code sometimes lasts longer than it should. Okay, let's see what's on the next slide because I don't remember. Yeah, so the idea that programming actually is kind of hard. And I think Fabiola's earlier comment about debugging, just this, if you can make your job harder with the code you write. You can write some really obtuse code that is difficult to debug, difficult to understand, and like I said, the 50-year-old Brian looking at the 25-year-old Brian's code, I forgot how that code was intended to work, and so I have to relearn it every time I look at it. And so just kind of keeping that in mind, that I should be writing my code in as straightforward a way as possible. And it's accepting the fact that I'm not as smart as 25-year-old Brian in many ways. Okay, so this starts to get into, are there actual action items that come out of this presentation? Something I can actually change the way I do stuff. So one of the things that I am a big fan of is that you show your code to other people. This Gerald Weinberg wrote this book in 1970 called The Psychology of Computer Programming. It's actually a good book. You can also buy it on Kindle. And the idea is that if you try to convince yourself that your code that you wrote, slaved over and wrote, is right, then you're likely to prove yourself right. That that code is great. I thought of everything. And one of the things that we do, I did. I no longer do that stuff. With LabVIEW R&D was all of our code was reviewed. I had to show it to somebody before I submitted it into Perforce. We do that across the street, except it's more of I don't just sit there and just show them the code and walk them through it. I actually submit it, and then somebody else offline goes and reviews it. Some groups that I do that as well. I actually like to sit down and explain my code to somebody, because when I explain my code to you, there's a good chance I'm going to see the bug in my code before you see the bug in my code. Because I'm verbalizing what this code does, and I'm maybe seeing how my verbalization, the wires and loops and all this other stuff, the error handling that's on the screen. And so you may be just a step behind me as you're trying to catch up to what I'm saying, but forcing me to explain it to you, I think, is a really good way of improving the quality of code. And then if nothing else, all these other times when people just sit there and look at my code and it says, oh, you forgot to check for errors there. You forgot this case. What about this negative case? What about this empty array case, et cetera? That's just, you weren't thinking about it. You were all obsessed about your particular use cases, and somebody else just comes in with about how they're thinking about your code. So this kind of leads towards, I think code review is really important. Which leads to my NI-week presentation. So come to my NI-week hands-on session on code review, which is a reprise of last year's which was a reprise of the previous years. But it's apparently popular, so they keep scheduling.
Even after you leave.
Any comments on this particular slide? Yes, Norm.
In the realm of programming or just kind of personal ideas in general, about the question of Steve Jobs, that there's a couple different ranges taken in, right? I wrote a function and I want somebody to review it versus I've done an architecture or I have my baby that I've created, and then kind of having that certain amount of arrogance, obviously humility and arrogance. But it was interesting. It's been interesting to see how Jobs' arrogance is driven, like his unilateral, my way is right. You guys just need to figure it out. I haven't read his book. What do you think about how his mentality has been able to take a company like Apple to where it is versus something along these lines, like being determined that you are right? That mentality, that kind of help.
I think there should be a distinction drawn between being protective of your vision and being obtuse to feedback on implementation. Amen. You should draw a line between protecting your vision and ignoring feedback on how it's implemented.
Yeah, I think I hadn't really thought much about like the Steve Jobs example, but I think there's the
Jobs never made an iPhone.
yeah. I mean, it's one thing for him to say, here's what the iPhone ought to be, but he's also not the guy to make all the design decisions. I mean, he was. I mean, he inserted himself into probably more processes than he needed to insert himself into. Maybe, I don't know. That was the way he ran his business. It was the hands-on. He made sure the decisions got made the right way. And then there's this question of how well does Apple operate in the post-Steve Jobs era. Other comments on this?
I'll just use you, Brian. The 12 years I've been in LabVIEW R&D, all of the process and paperwork and bug databases and everything that we have, the single most effective way to write good code that I've seen is talking about your code with the person next to you. Nothing else compares to that. I've seen and better implementation. I think that's it. Always happens because of the guy sitting next to you.
Yeah, so I'll just repeat that for the people on the phone, but basically Darren was agreeing that he felt like the review process of, we call it buddy bowling in LabVIEW R&D, because bowling is the process of submitting into the source code, Perforce, and buddy is just the guy you're explaining it to, the man or woman next to you. Goodbye, Norm. Goodbye. But just reiterating, that's one of the most valuable parts of the process of LabVIEW R&D is the fact that you're explaining your code to somebody else. And like I mentioned, it's not something, it's more detached in my current software group. Maybe that's something I can change over time. There's some code that I submitted today that I really felt like I wish I could sit with the architect who knew the most about it. Unfortunately, he's on vacation for a couple of weeks, so but that's how I want to write code, is to actually share this. Here's what I did. Did I do it right? Teach me, as a novice in this environment, how to do a better job. Okay, let's do this in the next slide. Okay, so code reviews. This is, I think, stolen from the code review presentation, but the purpose of code reviews is multifaceted. One is to find bugs, ensure code is readable and explainable. It also is a way for other people to learn, teaching, learning. Encouraging reuse. One of the things that was frustrating to me at certain points in LabVIEW R&D is when we added a bunch of people to the team who kind of had their own code base that they were bringing in. And so there's like this wall between the people who knew one code base, the people who knew this other code base, and so there's almost no reuse across that boundary. Because these people consorted with these people, and these people consorted with these people, and they didn't really cross that boundary very much. The more you can share your code, explain it to others, the more likely it's, oh, you know, I'm going to remember that I need a function that does that, and that you've got one. Fabiola.
Well, somebody in the audience was, the people that are connected remotely was saying, sometimes I have experience that if you show your code to less experienced developers, you also find your level of documentation is good enough or not. So it's not, so how do you get per person that reviews your code? It has different levels.
Yeah, so it works both ways. I mean, when I was a junior developer, I would look for a senior developer because I didn't have the confidence that I was doing things right. So I'd look for somebody senior, especially if it was important. When I was senior, sometimes I would look for a novice just because I had confidence in my code that it was right, and I thought it was a good teaching experience, and so I'd find a novice developer and say, hey, you know, you should really learn this. Let me show you this particular code. There were also times when, as a senior developer, I realized, my gosh, this is a really critical piece of code. I should get as many other senior developers to look at it so that we are all kind of agree that we're making the right decision on maybe something. And so, you know, I'll just mention teaching and learning again. To me, that process and choosing a good buddy is part of what we discuss in the code review hands-on at NIWeek is you know, if it's really important, you want to find somebody who can look at your code with a critical eye, ask the hard questions. Like on the LabVIEW R&D team, if I really wanted, you know, sometimes I just go ask Greg R. Because Greg Richardson was just most likely to give me a hard time about various like boundary cases or things like that. And so I'd be willing, I'm absolutely willing to take that punishment because I feel like if I can get this past Greg R., if he can look at it and say, yeah, I think it's ready to go, I felt higher confidence than, you know, showing it to somebody who'd been on the team for a month or two. That was an example. Well, yeah, it's better. Yes.
Quick question. Would you suppose you have multiple developers working on a project? Would you say it's sufficient enough to silo your individual aspects of the project and then code review, or to actually try and enmesh your code such that the other person has to use it and they have to use yours? You get it? Okay. You're nodding.
One, I don't necessarily think that there's one way that you need to do this stuff. Certainly in LabVIEW R&D, there was a lot of just very informal, let me just show you this. Here's the bug I'm trying to fix. Here's the one line that fixes it, or maybe a handful of lines that fix it. Other times it was like one of the members of my team wrote the example finder that took the LabVIEW. It's a fairly complicated queue-driven message handler architecture, and he brought in, I think, you know, about average of 5 people, or you know, about 5 different meetings that each lap maybe half long, and you know, significant investment into reviewing that code. And he had a particular strategy for how he's going to review that code, and so that's different code requires different levels of thing. Now, in terms of do I actually, you know, force you to use my code, you know, that's, to me, that's part of being a good reviewer is figuring out what the right level of me looking at your code is. And sometimes I really need to play around with the example finder and try and break it myself before I get into the code review. Or maybe as a result of the code review, I want to go play around with it some more. I don't know if that answered your question, but it depends.
Okay, we'll talk about it later.
Chris.
No, you think, yeah.
What I found is, I was using, I got the benefit of pushing on. Forced improvement. Now I have to wait on them. So you have, right, you're good.
Yeah, process allows
Yeah, so just to expand on that a little bit, the culture that I grew up in LabVIEW R&D is one that is not one of strong code ownership, meaning I have my code. If you want to change in my code, you come to me. That does not exist in LabVIEW R&D. One of the things Steve Rogers always said was, nobody owns code in LabVIEW except maybe Jeff K is allowed to say he owns code in LabVIEW, so his money. And so if I was going to make a change, maybe there's some core function call that I need to add a parameter to, or do something to. It's my responsibility to go visit all the places in LabVIEW that call that and update it to the new calling convention.
That becomes a practical deterrent. You have to create a sort of culture that motivates people to make that change without punishing them. Like, you can't just make a tweak here to get your stuff done. You've got to change 4 weeks worth of code across.
Yeah, well, some tools, like when C++ came along and had optional parameters and made it easier to go modify the parameters to function call in a compatible way, huge productivity gain. So obviously you want to take advantage of as many of the things like that as you can. But, if you really are making a change that really has the potential to impact 150 different places in the source code, it is incumbent upon you, in my opinion, to go visit those 150 places and decide whether your code is right for, whether it's all going to work when you're done. Don't just say it's...
I think that what I was envisioning was a culture that says you must change the dependency library, you can't wrap it in your own level library, and put the workaround in your own and not touch anybody else.
And that, yeah.
Punish the developer for getting.
Yeah, I really struggle when I need to write an abstraction layer on your abstraction layer because I like my abstraction layer better than your
Everything
abstraction.
can get out of hand. I don't think that it all has to be. I found that if you allow things like that, where get it done for your use case, you come in, you have a pain across the board, that motivates people to put a tweak in, so use the rest of the library.
Yeah, to me that's incurring software debt. I'm creating another layer that I'm going to have to maintain because I wasn't willing to fix the other layer. Because I just happened to look at some code like that today, and so it's kind of fresh on my mind. Of, hey, here's this workaround that somebody wrote in this one function because the core function didn't behave properly, and they were afraid to change the core function. Well, I'm going and changing the core function and to give the right answer, and so this code is now, I have to go remove that code that somebody else added. I have not convinced myself of that. Okay, let's move on to Major Dan Ward of the Air Force Research Lab. His theory is that so projects start out simple, very simple. They don't do a lot. They're just simple, and then you start adding more complexity to the code, and they can only go one of two directions. And this is they become more and more powerful to the point where in order to actually succeed at being powerful, they have to be simple enough to understand, or they collapse under their own weight and they get too complicated. So as an example, you start out with your PhD project and you eventually get your thesis and you rewrite it at some point and then you die. So that's one approach. And then part of the theory is that you should really be going this direction. And so there's this big split right here in the middle of, I have a choice of going one way or the other. And to me, this is where this simple solution is what's going to cause you to succeed here, as opposed to the clever, complicated solution. Damon.
This is actually one of my pet peeves. And it's a pet peeve because I've seen so many things start out simple, but too simple. There is such a thing as being too simple, and what it usually ends up happening is they start out very simple, then they find something that they need to do, and rather than going back, as Brian said, and fixing the original thing and increasing the complexity slightly, they instead keep the core too simple, add something on top of it, and then beautiful sandcastle, and then I need to put one more level on it, so you put one more level on it, and you get to a point where trying to add anything more to it keeps collapsing pieces of it. And if you had just said, well, if I just built this out of wood in the first place, it's harder, it takes longer, but it works.
But
that gets you this trajectory. You get at a certain point, you start out or maintain the right level of complexity. You maintain something that is maintainable. If you don't, you end up patching stuff on it all over the place, and it ends up horribly complex because you can't keep track of all the patches.
But to add to that, I think that a subtlety of your point is that, well, if we knew that this is what we were going to end up with, we would have just built it to begin with. But we had to actually kind of suffer between here and there to figure out what it was we needed to write. And so we had to move in the complex direction, kind of figure out, okay, if I were going to build this out of wood, now I know how to build it out of wood.
Right.
As opposed to, at least with sand, I can let some walls collapse if they're not important, and I can kind of get past that. Okay, so this is where I pick on so Darren's never going to live this down.
It's pretty exaggerated, the manner in which you portray.
I know, and I love it. I love that.
You're cool enough, Brian, that I let you get past. You portray me as the guy who wants the complicated solution.
Yeah.
Because that's usually totally not me. So please proceed.
Yeah, okay, I'm happy to do that. Well, I'm just glad that I finally convinced you that I was right. So once upon a time, this project of refactoring or have leading a team of people to refactor every LabVIEW example. And there was an example that was more or less acquire some data and put it in a graph. And so this was a paraphrasing of what the old example was trying to do.
This whole story is a paraphrasing.
Yeah. And Darren, in one of the meetings we were talking about this, said, no, every example more or less needs to be, was it a Q-driven message handler or a state machine? Basically, something like that. Clearly, the right. So I basically had to convince Darren that not every example needed to be based on the Q-driven message handler template. That perhaps the theme was no polling loops, right? No polling loops. This is a polling loop because clearly I am reading scale factor and stop every time through this loop. And leaving out all the details of by polling loop, he meant basically free running as fast as it possibly could loop that just is using up as much CPU time for no good reason, right? So, well, this loop doesn't do that, right? This loop is clocked by the data acquisition read, and so that is one of the things that makes this. It is a polling loop in terms of it is polling some front panel controls, but it's also actually needing to know those front panel controls during the loop while it is running. So there's reasons for why it is written. It is acceptable to be written this way. So anyway, that's an example of, to me, this simple solution is not as powerful as this complex solution, but as an example of trying to convince somebody how to use data acquisition read, I would rather have them start here than start in a Q-driven message handler.
This is interesting because one of your initial questions is what is the characteristic of code that lasts for 20 years? Talking about this idea of design and understanding the overall purpose. What you're showing right here is a teaching aid. So you want it to be as simple as possible. Clear and concise point. The other one is built so that it can be extended. We can add functionality very easily for two completely different purposes. Leads me to my overall question. Talk about this idea of over-architected built. How do you know when you're
Because there isn't a written requirement, a written traceable requirement for the code you're adding.
only if there's a written traceable?
Stop thinking ahead to things that were never required.
Yeah, well,
You're assuming the requirements are accurate.
See,
Which is the requirement maker that is correct?
Or
So,
complete, or
Staab's-
these are all down.
Staab's comment, to some extent I agree with Staab's comment, but I really think it falls again on the architect to know, even if it's not a written requirement, is it likely a requirement that is either implicit or is going to be explicit at some point down the road? And that's where an architect, that's one of the things where, my 20 plus years of experience is I know some stuff that's going to happen. I know that we're going to get caught by this lack of error handling or something like that. So that's part of the wisdom that somebody more experienced might be able to bring to a problem. Fabiola, you.
Yeah, so I don't want to use code example because then I'm going to try the same thing as that side. But just, I'm just going to use an architecture example. When you look at a $1 million house, right, that has a big yard, that might not have a swimming pool in it, good architect is probably going to put in place a bathroom that can be accessed from the outside of the yard. Just knowing, being a $1 million house, the likelihood of these guys putting a swimming pool on the backyard is pretty large, even though the swimming pool is not there right now. So it's the things that you know that might come later that make it better than having all the bathrooms in the center of the house. So now when the owner of this $1 million house builds the swimming pool, now they have to.
Well, I agree with that. I think it's more complex than that. One of the other things the architect is thinking about is, well, how much would it cost to add that bathroom later?
Yeah, and that's
Right?
yeah, that's the other.
Right, because it may be like if I start with this example, what is a feature that somebody is likely to ask me to extend this simple example? They're gonna say maybe multiple channels. Multiple channels. Well, guess what? I don't really have to change very much to support multiple channels in this example.
What if you want to use a non-NI DAC card?
Non-NI DAC, right? See, that's where I might be tempted to, we'll just replace this DAC read with an abstracted read. I still keep my same architecture. At some point, maybe somebody starts to pull me into changing the architecture. But I actually believe that this is just a good a place to start with extensibility as the other one. This one's kind of is a more complex way to begin with extensibility. To me, it's not really that difficult to add a bathroom to this chunk of code. Alan.
Going back to what Staab was saying about a written requirement, no customer is going to tell you, unless he's himself a Latin person who's going to look on his code base, no customer is going to tell you, I want to keep. They're going to tell you things like, hey, you need to have, I want to have these parallel. Or Brian was saying from their experience, okay, yeah, they want to stream this stuff to disk. Well, from having done that in the past, that you're going to need to offload that into logging factor in the general sense, not AS. So, there are things that the second slide is an implementation detail, not requirement. You shouldn't do it if you don't have the need for that level of architecture, but nobody's going to write down to do that.
Yeah, you're saying what I meant. I said that facetiously and succinctly, and I got
Well, and you said another.
That isn't necessary for the front panel that you just showed.
No.
And that's why it's wrong. If they said, I want this stuff, I want to see the graph in real time, I want to be able to stop acquisition at any point from user interaction, I want to change the scaling factor on the fly, and I want to know if the program crashes, you don't need the second example.
Right.
And that's what I mean by written requirements. There are 4 requirements on that panel, and they're all met by the minimal code.
What you just said is ever. I want to know these things for all time, from now
For
on.
any product, the business owner's responsibility is to have that imagination or vision within the scope of the business function.
When I want to,
I'm not going to want you to burn up a whole bunch of NRE for crap they'll never be able to sell.
when I want to reiterate that I believe that this is extensible. This simple solution is still extensible.
Yeah, absolutely.
It is not extensible in the same way as this,
I think that the implicit assumption in the second example is that you can only extend something in loops that already exist. Why the hell can't I add a loop to the inverse diagram?
No, that's exactly right, and I'll tell you something. Under my desk is a gallon of gas and a box of matches. If I have to sit down and what I'm told to do is give me an example that does this, right? Give me a proof of concept.
Somebody recording this?
Yeah. Give me a proof of concept for X, Y, Z. Yes, I know. I am the architect. I spend a lot of time about full but right, okay. So or somebody else on the team comes in because it probably was going to be somebody writes a POC on my team to solve some problem, and the POC is going to look a lot like that first slide. It's going to come back and say, well, that's great. Now we want a system that does all of these features. That's when the gallon gasoline comes out. Because
that's when you do what Brian said at the very beginning of his presentation. The first thing he said, you throw away your prototype and start.
Right. Exactly. The gallon gasoline.
That's extensibility. This code, it can be thrown away.
Right. Hey, this it's something. You know, the guy who brought us the waterfall model. The same paper told us, Vincent Royce, the same paper that he gave us the waterfall model doesn't work. You write it to figure out what you need to do.
For
and then
projects with $1 million budget, waterfall's awesome. I don't do anything with $1 million budget.
So there was something over here.
No,
Let me raise
it's
your hand.
Trust me, I've worked with this project.
I thought so. So, kind of go ahead.
You mentioned waterfall. Does anybody use Scrum?
Not formally, but I do.
Yeah.
You write it, even back, 30 years ago, 40 years ago, they were saying, you write it once. You write it once to figure out what your requirements are, and then you know what you need. You burn down the old code base.
So my final thought on this particular slide that's up right now is I do believe that this is scalable, modular, maybe not quite as reusable, certainly extensible and simple, right? I can extend this. I can keep going on this until the point where I shouldn't do that anymore. As an architect, I can say, hey, I've basically bolted on too much to this one loop thing, and then I need to throw away the prototype, and then that's when I probably move to something like this, because this is such a common design pattern in LabVIEW. But that doesn't mean I have to start there, and I can probably even salvage a lot of this code that I have here and move it into the other architecture. So I still believe that there's some reusability. So I'm not imposing on this that this must be, all the code I write must always be completely reusable, right? It doesn't have to be that way. Fabiola.
So Michael from BI Shop is asking, Brian, what's your opinion on integrators that use frameworks for everything?
That's dating.
You don't work for an eye anymore, you can tell the truth.
I think that if it lowers the cost of their implementation, because most of the codes are...
Well, my thought, Staab just said if it lowers the cost of their implementation, fine. I think that neglecting all the legal issues of, can somebody else take that same framework and reuse it without, having to go back to the company, and so, there's all that. I'll just leave all that out. Let's just assume that those are non-issues. I think if the frameworks themselves are simple and modular and reusable and scalable and all those other nice traits, then sure, fine. I tend to like frameworks that I can pick and choose when I incorporate them. Like one of my ongoing complaints about the Actor framework is it's pretty much you change your architecture to the Actor, it's pervasive that you are using the Actor framework.
Or you
compared to
you write a layer between them.
Yeah, and so I put out a challenge to Mercer, for example, to bury some of that Actor framework stuff under the. Show me an example that buries a lot of that Actor framework stuff. And that's coming. I think it's possible, but it's not there. Object-oriented programming is as a different example. I think it is easy to introduce OO into an existing application without changing its architecture. And so I can start to introduce OO in a more piecemeal way. So in terms of, it depends on what you call a framework, but, I believe that a framework where you can kind of pick and choose what I pull in and pull in what's appropriate and not have to bring in the entire framework, whatever that might be, that's what I would be looking for. Did that answer Michael's question?
Yes.
Awesome. Any other questions from the internet?
Brian, it's a fair point to say that somebody who is not humble will rarely ever choose what we're looking at right now. They'll always look for the more humble.
That's a sweeping generalization.
I strongly disagree. I think it'll be out either way. Right now, so right the second.
It's not going to be popular, but it's appreciate it. Just you think that can make sense, right?
Yeah.
Oh, but you know?
One of the, I forget, maybe Chris said it, I believe that there are clever programmers who would do this and then hide something under the boundary of the loop. Right? I'm highly confident that would happen. So, and in fact, you're more likely to see it in something like this than you are in something like this. I don't know. I'm done talking.
So, before we move on, I know Staab wants to do the open mic. Is anyone else wants to do open mic?
You mean like karaoke or what?
Yeah, he's gonna serenade us.
Beatbox to show off.
He's gonna serenade you, Brian. He's gonna do the farewell song.
Where's
So I
Ralph?
just wanted to make sure, I just wanted to get back, so only stop to I guess we can have 10 more minutes for questions.
What if we want to respond to whatever Staub's going to talk about?
Actually, that's the whole point, so 10 or 15 is plenty for me.
Well, why don't you just get up here and talk?
For Brian?
Hey, I enjoyed it. I enjoyed coming back here. What was that? See you tonight, week.
You're always welcome.
We love you, Brian.
You should come to LabVIEW.
Thanks for having me. So do you take back?
Yeah.
We're going to be a minute on the turnaround, right?
Yep. We'll take a pause. Prepare yourself.
Are you?
Or me.
Are you on the? Stop. Are you on the join me? I'm glad you were engaged. Stop. Are you on the join me?
No, it can be.
I'm assuming you look like you're using your laptop, right?
I'm sorry, what?
I'm assuming you use your laptop. Sí. Got it. We want to join on?
Sí, déjame un momento.
Put it in there 2 seconds. Really? Tell me that you should try it.
Oh, you're going to dynamic code?
Yeah.
9, 0, 515, 897.
Okay.
Download it.
was commenting, I know, the audience was like, something is good, and the guy said, it's like, oh, okay, so, like, I don't know, that was my question, I didn't get it. The idea was, infrastructure built around
Click on the do the 12 there. Okay, you're 33? Hey. Have you seen my containers? Have I already told you about it? I've been following the thread. What do you think? Right, because I agree with that. It's not an area.
Yeah. My daughter will pull out her laptop right now.
It doesn't have a performance benefit and it can't.
In Denmark, it was a combination.
You will take a penalty. Yeah, I err on the side of Python mentality. We're all considered adults here. Let's be responsible with our code and trust others to do the same. So I'll use the various library for customers for this situation every time. If that's what's natively available. I don't have to validate your libraries with unit tests you haven't provided. I don't have to worry about password protected section. I don't have general problems with LabVIEW. I don't have to worry about standard distribution. I don't have to worry about package repository, blah, blah, blah. I don't think that we stand together willing to so I'm speaking my skepticism not having seen. That's all. I started off with that and I haven't opened it. Okay. I just followed the discussion thread, just out of it. It's bookmarked for later on the list. I'm curious and skeptical. That's allowed. I'm not judging anything, but I have my not that you did it. I just figured that it isn't necessary. There's a lot of things that oh shit, I need that extra stuff. I need that extra stuff and I don't want to write the code. Well, that's, nobody works right now. Well, yes, like, I love your violent code. Whack watchdog. I took the verbiage from the NI watchdog. Oh. That's their function is called whack. Yeah, you beat the dog and he barks and you know he's still alive. That's what it is. There is on there. On the NI one. It says whack. Yeah. That's my customer. The watchdog implemented on the CSPA, so I can implement yeah. You should have had a picture of a stick up there instead of whack. Well, I only do a couple of glyphs on my code. I don't like these glyphs in general. So you'll see English on almost all of my custom code. Okay. Yeah, okay.
Where's Brian? Not the other Brian. Brian's here. I guess you're right.
He might be in the restroom.
All right, so I'll wait until he comes back, and just I realize I need to say things again. It's clear.
Hey, does it settle
Well,
on
I'm
the
sure
spot?
you've been doing it, but I'll do it again. All right.
What? Grumpy cat. Hi, my
name's David Staab. The locals sitting in the room know that I'm a consultant here in the Austin area. I worked for NI for about 7 years, went through the systems engineering role. I crossed paths with Alan as he was incoming and I was outgoing. The poor guy got to see me in my senioritis stage. But I've been doing a lot of embedded development since I left, almost entirely on the SVRIO and CRIO platforms. And I just want to show a little thing that I think I'm going to give away at NI Week because it's going to be in my talk on creating reliable embedded systems with the LabVIEW RT platform. I've got these little libraries I've been using for over a year now that I just throw into every application and they just work, which is nice, and they're simple, single-purpose libraries that they're things I feel like every application needs on an embedded product. The code you're looking at, my company owns through a fortuitous contract error, so it's my IP, but, you know, don't hit the record button and study it in detail because I didn't get permission from anybody since I own it. Yeah, no, it's not a big deal because I do own it, but it's just like, don't, you know, be a jerk and steal it. What I want to show you is I've got little...
At least understand that if you steal it, you're being a jerk.
Yeah, that's about it. It's kind of like an LGPL license. So please don't be a jerk is the license terms. I've got a couple little libraries like my RT LED blinker, and I provide the function that blinks the LED or turns the LED on and off if you call the function. You got to end up hitting the thing in a loop anyway, so I wrap that up in a little loop that spawns itself, and I've just got an API that fires up the blinker, lets me set the light on, off, or to any other state, and that state could be just blinking constantly. So I've got this one that says set the blink period, and then it hits the thing itself. So that when I launch the application successfully in this green error case, after all the init logic's done, I blink once a second on the user LED. And if I launch unsuccessfully, I blink 4 times a second. You've seen that on your router. Why aren't we doing it on our applications? It's just little stuff like that I want to show off and get ideas for. That API has those functions I showed you. Fire up the blinker, set the state permanently on, off, or to something else that's allowed by the input to the lower level API, and blink it at a specific fixed period. That's all it does. When I kill the blinker over here on the right, it turns off the LED, so it always ends in the off state. I've got another one that is a custom rolled watchdog. I find the NI watchdog is a little dramatic in that if it loses the RT, it resets the target, and it also has like an occurrence-based API so that you can watchdog certain processes and have another one take over certain things. It just didn't really meet my needs, and I find that almost all of my real I/O safety situations and process control apps require something to be done on the FPGA, which is always running until power failure. So I wrote a little API that, from the RT side, launches a watchdog whacker and does a keep alive against an IRQ and the FPGA. So on the RT side, I just initialize my whacker, and I have, in this application, I have a type def with the IRQs used by the app. So I tell it, hit the whack watchdog IRQ, and it keeps running. And then if this application halts, hangs, memory overload, crash, any of the fun things that can happen in the VxWorks OS, the FPGA within a quarter second puts all valve I/O, all temperature control, all PWMs to safe states within a quarter second. It's pretty straightforward, but it's something I do every time. So on the RT side, I've got a reusable library. And on the FPGA side, I've got a template DI that I drop that checks the IRQ, passes it out to a global, and then all my other loops can check the global and put things in safe states.
Same for 350 in the compact radio sample project, that I doubt we wrapped it in an API.
Yeah, you know, I just do it so much, I was like, okay, I'll take the extra 2 hours and make an API out of it. So it's there. And the last one that I want to go into a little bit of detail on is an event logger. I've relegated it to RT because I implemented it around the RT FIFO, so I could hit it from time loops. But it's a little event logger that tells me, like, it writes a byte stream. I actually take your strings and turn them into U8 arrays and pass them around the RT FIFO to the logging loop. And it breaks things up into multiple files according to a maximum file size. You can configure, I open the front panel of this little guy. You can configure where your logs are going to go on disk. You can give them a prefix, and I've got it hard set up so that it appends an ISO 8601 timestamp to the first event in the file so that they sort themselves by time. And it lets you use a config file to define different properties of the API, and the API exposes, I think I'm on an RT target right now. Yeah. It exposes a little palette for init and destroy the logger, and then you can log error events, info events, and debug events. Those are the only levels I've got defined because they're the only levels I've really needed. Error is always at the lowest level, so if you're doing error logging, you also get info and debug. If you're doing info, you also get debug. If you're doing debug, you just get debug, or vice versa, I'm sorry. It mirrors what you see in other standard logging platforms, where the lowest level priority gives you everything super verbose, and you can go higher level if you only want the more critical situations. And then the RT event is the lower level function that all the others call into, and, I'm just going nuts here on the keyboard. That's the one where it gets the FIFO and puts it into the FIFO. It'll also truncate the size of the message so that you can set a maximum message size to avoid reallocating weirdly when you're running on RT. I've tried to make it as memory safe as I can. The config file, right now, I only have 2 keys that you can hit. One is the level you're logging at, and when you init the logger in your application, it sucks that in and it logs at that level until you restart the app, or restart the logger, as it were. So you can turn logging off, error, info, and debug. And then the second key is context. You can, every time you log, set a context for that event so that it won't log if you're not logging that context, and you can have certain ones. So it sort of lets you create a Venn diagram of things that you do and don't want to see during this app run.
I'm kind of behind on catching up to what you're saying. So is it possible to, say, if I want to log every message, info on up,
Yeah.
and that goes to a file, and then something else happens, maybe there's another file that only has the higher level one? Can I do that?
I don't have multi-file logging yet. I thought about it, and I just didn't need it yet, so it's not in there. But that's why putting this in front of you guys is like, what else would you want to see? Is this cool enough already? Is there something that's obvious that everybody needs to think about, like multi-file, which could be a good idea?
One of the things in Unix, back when I used to manage Unix systems, there was like a configuration file that basically, something like 1 through 5.
That's where I took my idea for the levels. Yeah.
And you could basically specify, okay, info messages go to this file.
Yeah.
Maybe that file is dev null, some bitbucket or something like that. And maybe the most severe ones actually go to the console. So if there's an operator at the console, and maybe like on RT, if you had a head on that Rio device, that's where there's very critical things you really want somebody to notice.
Yeah, I did actually add console logging, and I haven't tested it yet, so it's not in this package. It's in the
So rather than have to change your program, for example, change this constant, you actually had we had a separate configuration file. That, okay, info messages I want to go here, debug messages I want to go there. And if it's there, then I go to it. If it's not there, then nothing happens to it.
Yeah, that's a cool idea. Just to repeat for the internet, Brian suggested that I allow you to set a different target for each level, and if the target's null, then it does nothing, as opposed to forcing you to log at only one level to just one file. And it seems like that could be something that could be added in without dramatically increasing the memory and footprint of the library or threatening to create weird allocation issues that could just spiral off over a 365-day operation cycle. Yeah, it's a cool idea.
It also lets you change things by just editing a file.
Well, that's what's going on here. I bake this into my RT.exe, deploy it, and then I'd ship it off to customer at error level logging. If they have a problem, I check the log, find the error, and I relaunch the app with that file changed to log at info level or at debug level, and I get a more verbose log having them recreate the problem. So, real use case, I could just open one of these little engines. This is just a recipe sequencer that has a messaging interface. So like if I get an exit event and I try to send a stop message to my network stream reader and that fails, I log the fact that it failed and I say the method event sequencer was the component that failed. And that goes into a string in my log file. And I just use it all over the place where the handling action is to push it to a log, or the handling action is just to notify and not freak out and die. This one right here, I want to know when my network links are connecting and disconnecting because I had a bug at one point where they were just doing that willy-nilly. So I just log an info event that it connected or disconnected. It's a logger. You use it how you think you should use it for your application. There isn't a standard one in LabVIEW, certainly not free, and it kind of just sprung up organically from my needs in embedded development. So, you guys do? Yeah, I use DETT for my actor framework. Actually, this application is split across multiple targets, and some of the code in the Windows DLL is AF-based. And I generate events to DETT, but that's only useful while it's running. And a lot of things happen when it's deployed in the field and you're not watching. And that's the purpose of logging to disk. I mean, there's Log4j and Log4net are huge libraries that have been around for a long time that everybody in the non-LabVIEW world uses. They've expanded them to other APIs and languages. And then syslog is for Unix-based sort of IT administrator applications. There's EFW, event logging for Windows, if you're logging to IT admin panel in Windows. There's a lot of logging libraries to disk for post-facto analysis. So I threw this one together for my RT apps, and I've used it in a bunch of them over more than a year, and it's been pretty stable thus far, so I thought maybe I'd just give this to people at NI Week. Who here sitting in the room works on C-RIO and single board RIO? Okay, that explains some of the blank bases. There's just a handful. You guys log stuff, right? I mean, if it's an actually embedded application that's going to be deployed to the field, you log things?
I do now.
Okay, that's fair. That's fair. You know, a lot of the ideas I get for reliability and testability in embedded systems, I get from looking at my network router at home. I'm like, it does it. Why am I not doing it? And following that guideline has really helped me put together some really rock-solid systems on LabVIEW RT. And incidentally, I'll be presenting on it at NI Week in 2 weeks.
Are you limiting the size of the log files?
Yep. And I break them up when they hit a max file size. It's hard-coded right now because I've never cared about changing it, but if I release it, I'll bring it out to a parameter.
David, do you distinguish between logging while you're developing and debugging, logging, or deploying? Use the same API, you leave the debugging in the code, or you use field logging?
Do I distinguish between logging during development and logging in the field? Yes, that's exactly why I have the levels. I have a build script that changes the level in the config file after I deploy the RT app. Like I build the app, push it, and then I have part of a build hook that goes onto the RT through FTP and changes the log level to error. It was in debug when I was writing the code. And that's part of my automated build to push the application out to the field.
Can I ask that question a different way?
Sure.
It seems like you could go overboard with every other line being an info or debug level thing. And so where do you draw that? Do you ever take some out just because maybe when I'm writing it and I'm trying to understand what's going on in the system and I need that level of detail, or maybe that's where the problems are, so I kind of focus on that. But then do I pull some of that back out because it's too much overhead?
Brian asked the question in a different context, which basically gets to what's my philosophy on when to log, when not to log, and what's too much logging. If I need to log extra information while debugging a specific feature, do I pull that later when it works? I err on the side, because this library is designed, if that context isn't being logged or if that level isn't being logged, it does a quick case structure check on a Boolean and moves on. I err on the side of leaving that stuff in and assigning a context. This was for the recipe sequencing feature, and I just won't enable that context if the feature is working. And I intentionally designed the library to run as fast as possible if it's not doing anything, to no op as fast as possible, so that I wouldn't have to strip out potentially valuable logging code from later on. I think that there's also prudence is necessary in all coding, and it's easy to just litter up your functional code with debugging code around it. And when a new developer or you 6 months later look at it, you're like, what the heck is actually going on in this app? There's so much infrastructure for the functional code. You've got to just, I think that's just, you do it to yourself and you realize you shouldn't do it next time, and you iterate and you get experience and you just don't. I've gotten to the level where I sort of have a feel for how much I want to pepper logging into my applications. It usually happens at the boundaries between asynchronous systems. It happens anytime I'm handling an error silently, or if I'm reporting an error to nobody, like fail gracefully situations, any messaging, any network activity. These are things that I need to look at after they went wrong, and I know that I'm going to have to log those. So I just kind of develop rules of thumb in my head for how to use it and when to use it. It's philosophy.
So, a quick follow-up to that. That sounds like a very powerful feature to have that you call context.
Yeah.
And, I imagine it might be, it's not like you could draw your code and say, this area or this piece of code is in this context. Are you going to well document that so that users can have a lot of flexibility to use this API?
Yeah, I'm, part of the reason I haven't released it is because I should use it 3 times before anybody else tries to use it. I feel sorry for everybody, so I try to make myself a guinea pig. But I err on the side of documentation and explanation. You might have noticed I talk a lot and I have opinions, and I will share those opinions happily in an online document alongside the code if I get to release it. Yeah, so I'll make sure that you understand how to use it. I'm not going to go as far as making it suitable for release on the Tools Network because, well, there's been a recent discussion about examples and stuff. I think that some of the requirements for release on the Tools Network get in the way of doing my real business, and so I just don't want to spend that time. If I release it, it'll be a Bitbucket repo with a wiki, and I'll throw up the link somewhere. Did you have a question?
Curious what you're doing in the timeout case. Is there something that happens in the background of this?
Yeah, this thing is it's a recipe sequencer, so unless it gets an interrupting message, it runs through a recipe that is carried in that shift register. It executes I/O events at a certain rate. Yeah.
Am I losing track of the logic here? I thought you said don't steal this or you'll be a jerk, but yet you're giving it away at NIW.
Don't steal the application code. Like I was showing full block diagrams that use this in context because I didn't have a demo ready. Like when I show it at NI Week, I'm going to have a sanitized demo. Yeah, and if I give something away, it'll be the logging library. Might be the LED blinker because that's just a toy that everyone needs. But I won't be giving away this full application. So that was the difference there. That's all. Just wanted to show it, see what you thought. I think Brian had a great idea there. Thanks, y'all.
Remind me and I'll send you a link to the description of that file just to give you some ideas.
Yeah, that's great. Cool.
You guys haven't signed in, please do sign in, including people from NI. Also, the last time we did this, I think showing code was probably one of the first meetings that we have, the first or second last meeting we had. I really enjoy this type of presentations, but you don't have to do a full 1-hour presentation. If you have something you're working on and you want to do a code review or just get ideas, like for example, Staab just got an idea from Brian. That time I presented, it was the undo library, and we ended up getting like 10 different versions of it, including Stephen Mercer doing one where you could undo transactions. So you can really grow your code. So that's another idea for presenting. One thing that I wanted to ask everyone here, we've been toying with the idea of starting a meetup, like joining the LabVIEW Architects Forum with a meetup or the regular users group meeting that happens during the day with a meetup. Does anybody have strong opinions about that? What's a meetup? Yeah. MEETUP. Have you heard about that? No? Okay. So there are meetups around town for programmers, or if you want to learn salsa, you can go and look for meetups for salsa. And there's tons for, I've seen for Python, I've seen for C++, for C, I've seen some for Java, but I haven't seen anything for LabVIEW. And I think it's pretty much because, it's normally the internal user group meetings. And I was just wondering if we would do a meetup and basically announce our regular meetings through that way. It will be interesting to get people that might have heard about LabVIEW, but.
So just another venue to advertise.
Yeah. Now the thing is, I don't know if we want to advertise this meeting because I have been to some of the meetups and I went to one where I walked in and I felt everything went over my head because everybody had been doing this for 2 years. So I feel like that's probably what's going to happen with this one, but maybe the regular users group meeting
That's regular. If you frame it correctly, I mean, it's a matter of. I don't think we need to filter out.
No.
Let them have the problem, and if they express that, we can say, well, there is a meeting for novices, it's the user group.
So you guys think it's a good idea?
Yeah, sure.
Yeah, just I just, we're kind of always the usual regular suspects, and I would like to grow it more to show to other people what we're doing. And I even was thinking if we can get maybe even a, developer from another environment to come present, that could be interesting. Yeah, right, yeah, right. So anyway, so that was the other thing. So thank you, Sixclear, for sponsoring the Join Me.
Sure.
Thank you, Darren, and thank you everyone for making it, and have fun at NI Week, and you know your homework, right? What's your homework? You already forgot? No, so the homework is, you're going to make a list of what presentations or presenters you would like to see after NI Week, and then I can go invite them to come present, and also think about, if you just want to do a 10-minute presentation next time, just let me know. Thank you very much, guys.
Thank you, Fabiola, for organizing.
Thank you, definitely.
Alan wants to say one more thing. and then
No,
you go.
I was volunteering for 10 minutes.
Okay, perfect. Thank you.
I'll have stuff I can announce.
All right.
Stuff I'm working on.
Thank you so much, Brian.
Thanks, guys.
I think you have to